Next question. Which one of the following statements is false? First statement, Raoult's law states that the vapor pressure of a component over a solution is proportional to its mole fraction. That is true. We know that the vapor pressure of a component like P1 for an example, it is directly proportional to the mole fraction of that component in the solution. So this is a true statement. Option B, osmotic pressure pi of the solution is given by equation pi is equal to mRT, where m is the molarity of the solution. That is true. It is capital M, that is molarity of the solution. Statement number C, correct order of osmotic pressure of 0.01 molar aqueous solution of each compound BaCl2, KCl, CH3COH and sucrose in this order. Okay. Now here concentration is same, the solvent is also same. So obviously the osmotic pressure will depend on the Van't Hoff factor I. Van't Hoff factor I is directly proportional to number of ions produced in the solution. Okay, let us see BaCl2. It will produce 2 ions, 3 ions. One is Ba2 plus and another 2Cl minus ion. So total 3 ions will be produced. Van't Hoff factor is equal to 3. In case of KCl, it will produce 2 ions. One is K plus, another is the Cl minus. Van't Hoff factor is equal to 2. In case of CH3COOH, acetic acid, it will also produce 2 ions. One is CH3COO minus, that is acetate ion, and H plus, I is equal to 2. Whereas in case of sucrose, C12H22O11, it will not undergo ionization. So Van't Hoff factor for sucrose will be equal to 1. So it is last. Its osmotic pressure will be least. Okay, BaCl2 will be having the greatest or highest osmotic pressure here because Van't Hoff factor is I. We need to compare in between KCl and CH3COH. KCl is the ionic compound. It is a strong electrolyte. Okay. Whereas CH3COH is the weak acid. It is a weak electrolyte. Okay. Strong electrolyte undergo complete dissociation very easily. Therefore, K plus and Cl minus ions will be produced very easily. On the contrary, weak acid like CH3COH, they will not undergo 100% dissociation or complete dissociation. Therefore, even though I value for both of them is equal to 2, osmotic pressure of KCl will be greater than that of the acetic acid. Therefore, this order given in the option C is correct. Option D, 2 sucrose solutions of same molality prepared in different solvents will have same freezing point depression. Okay, sucrose is the solvent which is same for both of them. Molality is also same, but solvent is changed. If you remember, the solvent or nature of the solvent is responsible for the value of Kf, that is nothing but a cryoscopic constant. If solvent is changed, Kf will be changed. If Kf is changed, delta Tf also will be changed. Delta Tf is nothing but the freezing point depression, because delta Tf is equal to Kf into molality. Right? As you can see, delta Tf and Kf are directly related to each other. If solvent is changed, Kf will change and delta Tf also will be different. So, 2 sucrose solutions in different solvents will not have same freezing point depression. So, option D is the false statement and hence correct answer for this question. So, in summary, we have learned first of all what is the meaning of solution, what are different types of the solution on the basis of 3 criteria, that is nature of the solid particles, their physical states and number of the constituent particles in the solution. Then after that we have also learnt about colligative properties. Colligative properties are nothing but the properties which are depending on only number of solid particles and not on the nature of the solid particles. 4 colligative properties we have learned: relative lowering of vapor pressure, elevation of boiling point, depression of freezing point and osmotic pressure. After that we have also learned the formulas for finding out the M2, that is nothing but the molar mass of unknown non-volatile solute, by using these 4 colligative properties, which is the main application or main advantage of all these 4 colligative properties. We have also learned about reverse osmosis, its application in the desalination of seawater. Osmosis examples in day-to-day life like eggshell and living cell also we have discussed. Then we have discussed about abnormal molar masses, in which we have seen the formulas for Van't Hoff factor I. Inclusion of Van't Hoff factor gave 4 new different formulas for 4 colligative properties. And then we have also seen that how this Van't Hoff factor is going to change or affect the colligative properties.